All right. Let's take a look at a graph problem, round trip 2. So what's going on here? We have n cities and m connections, that is a graph, and we want to find a cycle, a path that starts in the city, goes through some other cities, and returns to the starting city. And you can't repeat vertices on the cycle. That's fine though. If you were to get a repeat, that would be like a smaller cycle that you could just cut out the part between the two repeats. So we have the number of vertices, the number of edges, and then there are m edges. Importantly, they are one way. Right, this is round trip 2. You may remember round trip 1 from a while back. The difference between this one and that one is that in that one, the edges were undirected, and in this one, the edges are directed, which does make a difference, as we'll see. So we should print out the cycle, or we should print out impossible if there is no cycle. And it's 100,000 vertices and 200,000 edges. So you can use DFS to find a cycle, right? So DFS as opposed to BFS is you just, instead of like traversing the graph in like by order of distance, which is BFS, in DFS, you just like follow one path until it's over. So for example, if we did a BFS on this graph, we might go 1, 2, 3, 4, right? We're just following a path all the way down, and then there's nothing coming out of 4, so we go back to 3, and there's nothing else coming out of 3, so we go back to 2, and now we go here. This is the 5th vertex we visit, this edge and this edge. And so here there is a cycle, right? From 2 to 5 to 6 to 2. So in the undirected case, any edge that to a vertex you'd already seen before formed a cycle. But in the directed case, that's not true, right? This edge from 5 to 4 does not form a cycle, even though we've already seen 4. It's only a cycle if it's a node that's one of your ancestors. Or another way to put it is a node that you're in the middle of exploring, right? We're in the middle of exploring 1, 2, and 5, right? We haven't finished off all their children. 5 to 4 doesn't count because we're not in the middle of exploring 4. Right, there's no path back up from 4 to 5. So other than that, it's actually basically the same as the previous, as round trip 1. So let's do it. So we have n and m. And so we read in the edges, directed, so there's only an edge from A to B. Immediate iris stream, vector, namespace stirred, and LL. That should be it. Okay, we'll declare a bunch of global variables. It's more convenient for DFS. Okay, so if we see an edge to an active vertex, that is a cycle. If we see an edge to a vertex that we haven't seen before, a nicer way to put it. Right, so if we see an edge to an active vertex, so it started instead of active. So it's active if it started and it's not done. Then we find a cycle. If it's not started yet, then we start it. We don't want to follow edges back to our parent. That's just silly. And that should be it. So in this case, the cycle is y, well, it's x, which goes to y. So what do we have? We have this edge going up, and then all of these edges going down. Okay, so we should actually store the parents, because we need to follow these edges. We don't need this. So the graph looks like this, where we need to generate like the parents and then reverse it. So I'll just make that a deck. That will be easier. Okay, so we'll keep pushing. And then we want okay, so that should work. So once you find a cycle, you can just stop. And at the end, we print out impossible if we haven't found a cycle, and the cycle if we have. Deck. We need to like declare all of these variables. Probably read in N and M. Yeah, sure. So we need to one index the output. does not look correct though. So it should be 2, 1, 3, 2. We say something weird. But X and Y. Right. So 1 has an edge to 3, 3 has an edge to 2, and then 2 has an edge back to 1. I just say 1 to 3. That is not an edge. So 1 to 3 to 2 to 1. We should mark that we started this node. Okay, 3 to 1. That looks better. So 1 to 3 to 2 to 1. So, or alternatively, 3 to 2 to 1 to 3. We changed X, so this needs to be cycled up back. So 2 to 1 to 3 to 2. That seems reasonable. Okay. Wrong answer. Oh no. Okay, so we have duplicates in our answer. Oh, that's a bit odd. To 9 to 8 to nothing. I don't know about that. One to 2 to 3 to 4 to 5 to 6, and then nothing. Okay. 7 goes back to 6, is useless. 7 goes to 8. 8 is useless. Then we have 9 goes to 8, which is useless, and 10 goes to 9. which is also useless. But we need to write this. Okay. Why is this a problem? 10 to 9. 10 to 1. It's not even an edge. I think that's the issue. Okay. 10, 9, 8, 10. Sure. Still wrong. 1 to 2 to 1 is supposed to be valid. So I think we just are allowed to go to our parent. Cool. Yeah, 1 or more other cities. I think the previous cycle finding problem said 2 or more. Okay, well that was kind of a mess. I am not as comfortable with DFS as BFS, as it's perhaps obvious. So what was going on here? So we read in the input. We did our DFS from every node, right? So the graph might be disconnected into multiple components, so we can't just DFS from 0. We have to consider DFSing from everything. We have started and done, keep track of like where we are in the DFS for each node, and parent keeps track of where we are, where we came from, right? So started, you're supposed to call before you call DFS, and then done, you're supposed to call after you call DFS. So one of the bugs that I had was I wasn't doing that around here, so I need to do that. And also, I should only DFS into a node if I haven't done it before, so that I don't waste time. Yeah, this line is not really necessary. But what we need to do is for every edge that we have, if it's an edge to an active node, and we haven't already found an answer, then we're going to form a cycle. And the cycle is, if y is an active node, then it must be an ancestor of x. Because if it wasn't an ancestor, it would have been done already. And if it is an ancestor, then we can form a cycle by going from x to y, and then down the ancestor tree until we hit x again. So how do we actually sort of form that cycle? Because we have up the ancestor tree, right? But we don't know like which way down to get to x. So we form it sort of in reverse, right? We're starting from the end, we push x, then we go to the parent, then we push px, then we go to the parent, then we push p of x, and so on until we hit y, and then we push y, and then we push x again, which is just the thing at the back of the cycle. It's not the variable x anymore, right? Because x is actually walked up to y. But this is just the back of the cycle, so that's what I'm doing. Okay, so that's the case where we're done, right? We found the answer. Otherwise, if we find a new node that we haven't started yet, then we should start it. We should mark down that its parent was x. We can do the DFS, and then we can mark down that it's done. And at the end, if we found a cycle, if we didn't find a cycle, impossible. If we did find a cycle, then just print it out. Yeah, so that's it. A couple bugs on my end, but hopefully the final code is nice and understandable.